Hello everyone. Right. Hello everyone. My name's Olivier Crête. I work for Collabora. I've been there since 2007. I've been involved in GNOME since 2000, starting with ICQ, an ICQ client, and then moving on to video calls, and then moving on to general GStreamer. I spent quite a few years working for Nokia back when they were making phones with GStreamer. And now I'm the multimedia lead for Collabora. So I'm going to talk about CI. CI is continuous integration. And when I say CI, I really mean CI/AT, continuous integration and automated testing. Because doing builds is nice, but testing something is better. So why do we do CI, right? Why do we as a GStreamer community do CI? Because we want to test things automatically. Why do we want to test things? Because we don't want things to regress. We want things that we've made work keep on working. And we want to test in a way that is reproducible. So we have a CI system that Edward and Co set up a couple of years ago. And we do quite a few builds now. So we build for Debian, we build for Fedora, x86-64. We cross-compile to Windows, both in 32 and 64-bit. We build for iOS, we build for macOS, we build for Android. We have all of these builds. So what do we test? Debian, x86-64, Fedora, x86-64. So we don't even test any 32-bit platform. We don't test any embedded system. Yeah, and I would say most people use GStreamer on an embedded system. Although this year, there's so many cloud and Windows people that maybe it's not true anymore. But at least a lot of people use an embedded system, and we don't test that. We have no idea if it's still working. And for a lot of people in embedded systems, they will not test the new GStreamer release until it comes into Yocto, maybe a year later, and then we'll be like, oh, this is a really old version that you're testing. It's a bug, but maybe you should try the new version. And so we don't have any kind of QA for these systems. So what's not tested? So currently in GStreamer, we test the demuxers, the muxers, the RTSP server, things that have unit tests. We test a lot of things. Software decoders, software encoders. But there are quite a few components in GStreamer that are quite complex and that we have zero testing for. Starting with our OpenMax integration layer, we have absolutely no tests for that. People just try it by hand until it fails. Hardware codecs, here I mean video for Linux hardware codecs. There's going to be a talk tomorrow about that. There's been a lot of progress there from the kernel community to support more hardware with standard Linux without special drivers. And the GStreamer plugin for that is now quite complicated. It supports 5 different modes of sending memory in or out. It supports transform element encoders, decoders, source sinks. None of this is tested automatically. It has all to be tested manually. So whenever someone makes a little patch, all of these things have to be tested to make sure there's no regression. It's a huge pain. Capture devices, video cameras, decklink cards, things like webcams. We don't know if it works, right? It might work, it might not work. It's a surprise. KMS integration to display on the screen. Any kind of zero copy path, we don't know if it's going to work, right? It has worked once in the past, we know that. But on your specific device or on any device, we don't really know if it works. So what we've decided to do at Collabora is last summer to do a prototype of a CI pipeline of GStreamer on an embedded platform. So to do a CI pipeline, we need two things. We need a GStreamer build, and we need an embedded platform. I chose the Raspberry Pi 3 because there were 3 on my desk, basically. And I thought this is something that a lot of people have, so if we test that, it's going to benefit probably the most people, and also other people will be able to play with it. But also the Raspberry Pi is interesting because until recently, it was a very special system. So the GL stack, you need to do some special manipulation to make it work. There is like a special stuff in our GL library for Raspberry Pi. They use GST-UMX for their codecs, which is a bit with a special build for that. So there's a lot of tricky things. So I thought if we get that working, everything else will be easier. And we can then make the rest work later. So first thing, before we can do any running, we need to build stuff. That requires building a sysroot for that system so that we have something to build against. To build this sysroot, we use something called Debus, which is something that's been developed at Collabora, and that creates sysroots, build images, but also system images that you can flash on devices using Debian-based packages, meaning that we can build a sysroot from an embedded system without compiling a single line of code. So you can just take deb packages, it installs them together. There's a lot of other systems that do that, but the sysroot, the Debus thing, has a nice templating system, and you can tell it like you install these packages and you delete like /user-doc because we don't care. You can delete a bunch of things and all have this with templates so that you can build many different systems and many different related images from the same basic setup. So once we created this image, now we have something to target against. Then we need to build GStreamer. We chose to use Cerbero because it's the easiest way to build GStreamer and all its dependencies. We created a custom Cerbero config, the things in config / in Cerbero. We created this config that is based on the standard Linux one, but has a couple special things. First, we select the toolchain in it. So Cerbero has everything you need to tell it, use this toolchain to build. We tell it where the sysroot is, so against what target to build on. And we created a special variant that wasn't typed correctly here, which is called RPi, Raspberry Pi. And that enables these options that you have like in the GL library and builds the GST-UMX for Raspberry Pi. So there's a couple system-specific variants that we enable there. And with this, we can build GStreamer for the Raspberry Pi. Now we have a build, but now we need to set up the board. The board is on my desk. That's nice, but that's not really useful for continuous integration. For that, we need an infrastructure. Luckily for us, our friends at Linaro have built a tool exactly to do that. It's called Lava. What Lava does is that you connect runners to it, and to these runners you connect embedded boards. And it has a number of features for these boards that you enable on each board. First, you have something to reset it. So on many systems, all we have some kind of managed power bar or managed power source that you can like turn off the power and restart it. Then Lava can you give Lava a kernel, a sysroot, and then it will boot the board using that kernel, and that's sysroot. And once that has happened, it will send the commands to the board, or it can do it event-send commands while booting. For example, most of them now, we don't really flash them. We do an NFS boot. And so it will connect using the serial port and tell the U-boot like which kernel with all the TFTP parameters and all of these things. And then it connects to the board. It can connect over serial or over SSH, which is a bit better, and then run things on the board. So Lava is a bit painful to set up. The nice thing is that we didn't have to set it up because Collabora and quite a few other companies run Lava instances as part of the kernel CI project. So our instance has 16 different boards connected to it. The kernel CI's project has over 237 different boards distributed between us, Belibre, Linaro, and other companies on the other sites. And the kernel CI thing is really nice because it's all centralized. So there's like a nice web UI where you can see the results from these 200 boards. And our setup has a Raspberry Pi 2B there. So we use this board for our testing. And the thing that the kernel CI people, they don't have so many builds a day, so we can actually share the boards with them using Lava, which is nice. So it will have queues and might run some GStreamer builds, some kernel builds transparently, so we don't need to set up an entirely new infrastructure for GStreamer. So for Lava, we need 3 things. First, we need a kernel. Since we're not really testing the kernel, we just picked a known working build from kernel CI, and we use that as our kernel. Then we need a sysroot, and this is the sysroot that we built a couple steps earlier. So from the same deboss config that we used to build our development sysroot, we can also build a bootable sysroot for Lava. And then we need a Lava config where we say use this sysroot, use this kernel, and then do these steps. Steps here would be like running gst-validate, for example. So what is our testing process? First time, so the way our process works is that first we build. And we're using Jenkins to build. But right now we haven't done it using the GStreamer Jenkins because we're using Docker. And the GStreamer Jenkins doesn't use Docker. So we used the Jenkins from Collabora that we have in-house to the builds, but our hope is then to move it to GitLab later. And then you trigger Lava. Then Lava boots the device. The device will download the GStreamer artifact. So since we're always using the same sysroot, we just download the GStreamer build on top of it after the device is booted. The device runs the test. We run gst-validate, for example, with some parameters. And then we get a JUnit compatible report. And then the device will send it back to Lava. And then Lava sends it back to Jenkins. And then we have our embedded report with our build in Jenkins all in one place. How do we integrate Lava and Jenkins? That's a bit of the tricky thing. We use something called LQA, Lava QA, I think. And it's a command line tool to send requests to Lava because Lava's API is REST. So having this nice command line tool, we can just put all the parameters and boom, it sends it to Lava and puts it in a queue. Since Lava is a queue and you can wait a bit of time before you get access to the board, currently in Jenkins, we don't want to block our runner while this happens. But Jenkins has a plugin where you can say this task is ongoing even though there's no runner running, and it will finish once you call back a webhook. So we're currently using this Jenkins plugin. And using that, we get the entire pipeline from commit to embedded results all the way back to the developer. So this is what we have today. The next step that we would like to do is not only have the Raspberry Pi, but have a standard Linux platform where we have v4L2 codecs, KMS for display, etc., so that we can test like the upstream kernel and not some embedded kernel. And we would like to make a test suite for gst-validate for embedded use cases. And I was talking to Edward last night. We're brainstorming and saying we actually need more test suite for gst-validate for industry-specific or use case-specific testing. So mainly a test suite for like broadcast use cases that might take a long time to run, right? So that we can do these, or we might want to have something for let's say security camera use cases. It would be really good for people who work in these different industries and know what their use cases are to contribute there. And maybe if people have specific hardware that they really care about, contribute hardware, maybe runners, join us, and we can have. My goal in the end would be to have all of these be integrated in the GStreamer build, so that when you make a merge request or a commit to the mainline GStreamer, we can test use cases and hardware across all of the various industries that people care about, so that we'll have a better result, and that on release it's actually usable by everyone, instead of having a couple point releases while people just try it for the first time after 6 months of development. So this basically is what we've accomplished and what we wish to accomplish. The next step I'm missing here is that everything we've done right now is on Jenkins. This is why it has not been deployed yet, because we're moving to GitLab. And GitLab has GitLab CI, which is much more simple and much less Java than Jenkins, and therefore more reliable. And we want to basically port all of our Jenkins file into a GitLab CI config, which is trivial, and find a solution to the use of that Jenkins plugin to get the information back. Our current idea is to have runners that only run one command, which is LQA, and block for a long time, and have like a large number of these runners because they don't take any resources. So I have a special runner that ends up talking to Lava. That's our current idea, but that has not been done yet. So I was kind of waiting for GStreamer to move to GitLab to experiment with that. So we've been like procrastinating that for months. First, I would like to thank some people also. Last, Omar Akila, who's not here, who was my intern last summer and who did all the work. So I didn't do any work, right? I would like to thank also Nicolas Dufresne, who might be here, who also helped me supervise Omar, and who has done a lot of work around the video for Linux space and hardware integration and GS2MX recently. So really kind of pushed us to make this happen. Guillaume Tucker, who's one of the developers of kernel CI at Collabora, and we've been doing a lot of work around CI on embedded platform, CI for ARM, CI for Chromebooks, for all of these so he's done a lot of the work to create all the infrastructure that we can then apply kind of for free to GStreamer, because they've done all the hard work. And also Sherd, who's our core lead, who has been the key driver of this infrastructure in the community. All the configuration for this, they're all on our Collabora GitLab. So there's the Jenkins config, the Lava config, the Docker files to build the images. Basically, everything we've done is available here. But as soon as we move to GitLab, I will port everything to GitLab and make this hopefully more beneficial GStreamer project. So, thank you for listening, and I'm open to questions. Yes?
So you mentioned that you were going to run those tests on devices for each. Sorry. So you mentioned at the beginning in your presentation that you're going to run those tests on devices for pull requests after we move to GitLab, right? How are you going to scale that solution? So who's going to provide all those devices that are used for running those tests? Because I can imagine a situation where, I don't know, more and more people start contributing to GStreamer, and we might run out of the devices. We might have very long queues, and how are you going to scale that?
So that's a good question, and so we're thinking of multiple things. Maybe on pull requests only have some subset of devices that are either very fast or we have a lot of. So for example, Raspberry Pi, they're like $35. So if we need to buy 20, it's not much. Another thing that we would really like to have the hardware vendors, device vendors be involved, and they can give us devices, right? For other use cases, or maybe some tests just take a long time, we might not do everything on every pull request. We might just run some of the Git master like once a day or 2 times a day just to. So it's probably going to be a mix, and what exactly is run on every pull request will really depend on the performance that we get. We're thinking of doing things like having a smaller test suite for every merge request and a larger test suite that is run more often. So the plan is in flux. So So I'm most interested in getting something rather than nothing, and then we'll iterate. Yes,
Do you have
Sebastian?
plans for supporting iOS and Android, or ideas how that could be done?
So and iOS and Android. So for Android, Thibaut has started doing something, and I would love if we could have that integrated. I think on Lavars, it would be quite easy to integrate this as a runner, a special runner, either with GitLab CI or something like that. It's just a matter of rebasing all of his patches on the latest validate. For iOS, I guess someone will have to do the same thing. One thing that we should do in the very short term is actually build an iOS and an Android application in our CI. Because right now, we don't even know if it builds, if you can make an actual application. Yes? Was there a question there on the left, or no? All right. Yes.
Did you do some performance regression detection?
Not yet. But it would be great if people can contribute tests. I guess ideally it's something integrated to the gst-validate framework, and then we could run these. So that is, especially like on the embedded world, I guess also on PCs, like it's important, like an embedded world, it's really easy to screw up like the alignment or the tiling or little things, and then boom, it does a mem copy, and your beautiful 4K playback runs at 5 frames per second, right? And then you've lost. Yes.
Do you run Cerbero inside the Raspberry Pi, or does it run outside to cross-compile GStreamer?
So right now we're cross-compiling on the server, on the cloud. So basically, all of these builds are done in Docker containers in the cloud. Yeah, because compiling on an embedded devices, that's not doable in reasonable time. Any more questions? Well, thank you very much then.